Lesson 2.5, Model Direct Variation. Direct variation is a special type of linear model. It's y equals ax and can be used to model many things. Notice that's similar to y equals mx plus b, where a is the slope and b is 0. For direct variation, we call a the constant of variation, which is the same thing as the slope of the line. So let's write a direct variation equation that has the given ordered pair as a solution. So we already know, because it's direct variation, that our model is y equals ax. So let's fill in the x and the y coordinates. So the y is -2 and the x is 6. Solve for a by dividing by the 6 and reducing the fraction, so a is -1/3. Now, write the equation. It's y equals ax, fill in a, so it's y equals -1/3 x. Another example from physics. Hooke's law states that the distance a spring stretches varies directly with the force F that is applied to it. So suppose a spring stretches 15 inches when a force of 9 pounds is applied. Write an equation to relate d to F. Well, notice back in the first sentence that the distance comes first, and then it says varies directly with the force F. So we're going to start off with d and say it equals a times F. Because the d came first, the F came second, and the varies directly, that's the equals a times. We can fill in the 15 inches for the d and the 9 pounds for the force. Solve for a by dividing by the 9, and you get 15/9, which reduces to 5/3. So now we can write our equation. D equals AF, fill in the 5/3 for the A, so D equals 5/3 F. So now we can predict the distance a spring will stretch when 6 pounds is applied. Okay, 6 pounds is the force, so we fill in 6 for the F. So 5/3 times 6 is 10 inches. We predict the spring will stretch 10 inches. The dimensions of 5 rectangles, each the area of 24 square feet, are given in the table. Tell whether the length and width show direct variation. If so, write an equation that relates the quantities. Now, if it's direct variation, we know that we're going to use the model y equals ax. So what we're going to do is take each coordinate and fill it in for x and y. And we'll see if a is constant, because a was called the constant of variation, meaning it shouldn't change. So let's take the first point, the 1 and 24, and fill it in for x and y. You can see a is 24. Let's try the next point, 2 and 12, and fill it in for x and y. If we do that, then a is 6. Since 24 and 6 are not the same, a is not constant, and it is not direct variation. And that's the lesson today. Here's your assignment.